In this video, we're going to go over a few examples of some linear inequalities. When we have a linear inequality, we want to solve the inequality. We want to write the solution in interval notation, and we want to graph the solution on a number line. So this will be the procedure we go through. So the first one, we have 7x minus 11 less than 2 times x minus 3. So we solve these in much the same way that we solve an equation. We work to simplify each side independently, and then group all of the variables to one side and the constants to the other side, and then we can solve. So add 11, 5x less than 5, x is less than 1. So we'd say that this is the solution, x less than 1. And then graphing this on a number line, well, we really just need to put a single value on the number line. We can put more values if we want. And what this is saying is x is everything less than 1. So less than 1 is going to be everything to the left of 1 here. Okay. Sometimes you'll see this graph with a circle on 1, and a circle just means everything up to 1 but not including 1. So the open circle and the parenthesis are analogous. And then in interval notation, well, this is going to be everything from negative infinity up to 1 but not including 1. So we've solved this, we've written this in interval notation, and we've graphed the solution on a number line. Okay, a second one here. This should be a 7. 2x plus 7 less than or equal to 1. So same thing, solve, graph, and write this in interval notation. So I'm going to subtract 7 from both sides. We get 2x less than or equal to negative 6. And then divide both sides by 2 here. So we get x less than or equal to negative 3. So on a number line, we're going to say less than negative 2, less than or equal to negative 2. So it's going to be everything over here. And then in interval notation, it's helpful to just write interval notation directly under the number line. Things just line up nicely for us. Now this example is not in the notes, but I want to emphasize something here. So suppose I have 8 minus 5x, let's do less than 10. Okay, so subtract 8 from both sides, negative 5x less than 2. Now when we divide by negative 5, we need to reverse the inequality. So anytime we divide by a negative, we reverse the inequality. So this is going to be x is greater than negative 2/5. Okay, so that's a key point here. When dividing or multiplying by a negative, reverse the inequality. That's kind of the only thing that we need to be aware of here that's different than solving an equation. So x is greater than negative 2/5. Greater than is going to be a parenthesis, and since we're greater, we're going to be shading to the right. Let's make that an arrow, and then the interval notation, negative 2/5 up to infinity, and that'll do it. Okay, so what we have here is a compound inequality, and a compound inequality is separated by, this one is separated by the word and. Compound inequality is present when we have two inequality symbols. So we just solve them separately, and then at the end we can combine their solutions. So this one over here on the left, we have 2x minus 6 plus 5 less than 9. 2x minus 1 less than 9. So x is less than 5. Then on the right side, we'll have 3 minus 3x minus 2 less than or equal to 7. This will be 1 minus 3x less than or equal to 7. Subtract 1 from both sides. And then divide by negative 3. And again, we're dividing by a negative, so we reverse the inequality. Okay, so let's combine both of these solutions here. What this is saying is x is less than 5 and x is greater than or equal to negative 2. So if we think about these on a number line, well, this is going to be 5 less than 5, so we're going to shade to the left from 5. And then greater than or equal to negative 2, well, negative 2 is here. Greater than or equal to that, we're going to shade to the right. So what's happening is the shaded part is running into each other. So if we combine these into a single inequality, we would say negative 2 to 5, bracket on negative 2, parenthesis on 5, and we're going to shade right in the middle here. And then in interval notation, it follows directly from this. So there's the solution in interval notation. So to write the solution, we graphed the solution, we wrote the solution in interval notation. Now because this is an and, we can write this either x is less than 5 and x is greater than or equal to negative 2. We could write it like that, or we could write it with x in the middle, so x is less than 5, but x is greater than or equal to negative 2. Either way is appropriate. You'll probably see this way in the box more frequently.